Hello everyone, welcome to the Microdesk webinar series. My name is Ravali Ravilapati and I'm the Marketing Manager for the Western region. Welcome to today's webinar, Making the Design and Fabrication Connection with Revit Structure and AutoCAD Structural Detailing. On this slide, for those of you who aren't familiar with us, I'm going to give you a little background of who Microdesk is. We're an Autodesk Gold, Oracle, and Google partner. We provide technology training and consulting solutions for the AEC industry. We have 12 offices located throughout the East and West Coast with a staff of over 90 consulting and technical specialists. On the next slide, presenting today's session is Microdesk Solution Specialist Josh Gionfriddo. Josh is responsible for providing training, implementation, and consulting services to our structural engineering clients. He's knowledgeable in AutoCAD, Revit Structure, and AutoCAD Structural Detailing. He regularly teaches training classes, helps create and execute implementation plans, and provides on-site support and chatting services to leading structural engineering firms throughout the nation. The next slide, over the next hour, you'll see that in the past, structural engineering designs were remodeled within detailing software by technicians, a process that was open to interpretation and error, and that was very time consuming. New extensions within Revit Structure 2012 that link to AutoCAD Structural Detailing allows designs to be imported directly into a fabrication model. This interoperability saves time, reduces costs, and assures design intent is upheld. In this session, we'll also explore this new workflow by exporting a structural model to ASD and show the ease by which shop drawing can be generated quickly and accurately. I'm going to go over just a few logistics before we begin. In order to minimize any background distractions, you're all on mute for the duration of the session. If you have any questions during the presentation, please type them in the question area of the webinar toolbar to the right of your screen. Josh will address as many questions as he can at the end of the presentation. And if we run out of time, we'll be sure to provide you with our contact information so you can follow up with us. And now I'll turn it over to Josh.
Thanks, Ravali. So as was mentioned, in the past, there's been some issues with transferring files between Revit and third-party detailing softwares such as SDS2 and Tekla. The file transfer between Revit Structure and those third-party detailing softwares is an iffy process at best. Off the bat, curved members, openings, cuts, and fittings are not supported in that transfer. In addition, looking at this screenshot from a third-party detailing software of a Revit model imported using the available IFC file format, we can see that the columns have disassociated themselves with the rest of the structure. It is typical for IFC files to display this type of misread, as IFC files take the lowest common denominator approach. File parameters and properties are not maintained accurately, and errors are unpredictable. In the past, engineers have been uncomfortable having their designs interpreted by software when they see these types of results, typically making complete remodel necessary. AutoCAD Structural Detailing is the solution to this problem. We can import Revit models directly to ASD, maintaining all parameters, properties, slopes, curves, and holes. So let's jump into Revit and see how that workflow works. So I'm going to go ahead and open Revit. I went ahead and modeled a very simple frame, just something that will allow us to send it over to ASD and add a few connections and see how we can generate those shop drawings. I went ahead with a pretty simple model because there is a time issue with getting all the elements read from their native Revit file and imported into ASD. So for ease of and time on the webinar, I went ahead and pretty simple model here. So in the Revit, you'll see up at the top where we have multiple tabs, there's a new extensions tab. In the past, any of these types of links would have been on your add-ins tab. The add-ins tab is now reserved for third-party links only. So you'll see I have my blue beam links here. And all Autodesk links will be on your extensions tab now. So they've broken those apart. And you'll see we have the AutoCAD Structural Detailing tab. So we can pull that down, and we have a couple options. If this were a concrete building, we can use ASD to do our reinforcing, but we're going to go ahead and use the steel data link today. And now we have a couple of options. We can send this straight to ASD if we have that installed on our machine, which we do. Or if we didn't, if we wanted to create a file that can be read into ASD, we can export to a DWG file. So we'll go ahead and use the direct link. So now it's reading the members and creating a mapping of the different elements. You see in here we have a database selected. I'm going to go ahead, expand that out, and look for the AISC shapes database and bring that into my project. And I'm actually going to delete this one right out. And you'll see now that these sizes in Revit are linking to sizes in ASD using that AISD database. And to verify that everything in my model is mapped, you can choose unmapped and see if anything isn't mapping correctly. It looks like everything in our model is going to be okay. So we can say okay. And this will start sending these elements into ASD. Now you see it's taking a few seconds to think. Sections and elements are being created. And because I had ASD running already in the background and the model is pretty small, that went fairly fast. So now we can switch over to ASD. And you'll see the model has been brought in. I'm going to get my view a little nicer. And you'll see this is a typical AutoCAD type form interface. And at the top, when we select drafting and annotation, that's what puts this into an AutoCAD interface. If we were to drop that down, you'll see we have an option here where we can choose ASD. We also have ASD Classic, which was more of a menu-based. ASD Steel, the new one, is more of the ribbon-based that you're used to in the new versions of Revit. So we'll select to display our interface in that mode. And now we have options for adding connections, adding positions, grouping elements. The first step I'm going to do before I start making some connections is just change this view. So I'm going to go into View, change the 2D wireframe look into a more realistic. Makes our objects a little more solid, looks a little cleaner. Okay, if we zoom in, we see that elements that were in Revit that had cut back extensions, that information is lost. But as we add the connections, the copes will come back. Let's jump right in and we'll add our first connection. There's many predefined connections, and we're going to go and do the column to beam with a clip angle. And that'll be the beam to column flange clip angle. Now the question comes up, where do I get the information on what I'm going to model here? So by clicking the column, clicking the beam, I launch the interface for the connection. And this is a macro-driven connection. And to get the information, typically fabricators would have been supplied with a calc package from a connection engineer. And here's one of those typical packages. So you can see we got the detail shown, and we have a table listing our different angle sizes, bolts, and then in the detail we got the spacing shown. So we're going to duplicate this connection in ASD. Back to ASD. All right. So it was a double angle connection, and that's here, left and right. We could also go up and down if we had angle seats. The steel in our detail was to be A36. So you can see that there's many steel properties in here, and you can just grab the one that you need. We are going to use a 4x4 by 3/8 double angle connection. So we'll need to load that into our project, and that can be done right here on database. So when we go to that, we'll bring up a dialog box that allows us to choose angles and select the 4x4 by 3/8 and insert it in our project. Okay, and now that'll be available in our drop-down selection. We'll choose the 4x4 by 3/8. We'll next look at the different holes. According to our detail, it was going to be 1 column of bolts and 3 rows. The spacing was 3 inches between rows, so we could set that here. Each row has its own spacing, separated by the comma. So if there were irregular spacing, you can set that. And horizontal spacing will center the holes in the angle, which is good. We control the bolts down at the bottom. We have two options. We can change the diameter and the grade right here. And then if we go into settings, we can also change them in there. And we get a few more settings, such as adding front and back washers, which we will. We can add locking nuts if we so desired. And here we can change bolt sizing. Let's use a typical 3/4 inch A325 bolt. And you can also set where this bolting will be done. Will it be done in the shop, or will it be done on site? You can set the bolt length to either be automatically determined or for yourself to determine that exact length if so desired. We'll say OK. Then we come back into this dialog box. And you'll see that the hole size has been updated per AISC standard holes. And we have the 3/4 A325 showing now. So that's the bolts from, that's the connection that's in the beam. Now we'll look at the connection in the column. And again, we want to set the bolt size to 3/4, A325, 1 column, 3 rows with 3-inch spacing. Okay. And that'll also be bolted. If we wanted to weld it, we could. We could weld to both. We could bolt to both. The option is ours. And so we'll say OK. And you can see that connection was made. Not quite what I wanted. Not quite the connection I was expecting, but we can click on this white circle represents that connection. If you're trying to select the connection, you use the white circle. If you want to, if that white circle is not showing, you can obtain that through preferences, structural detailing, steel, and then connection marks is what controls the visibility of those selectors. So if we wanted to modify that, we could right-click and say Modify. And that'll bring us in back into the dialog box. Let's look at the connection for the column to the beam. For that one, I'm going to use a clip angle, or sorry, a shear plate, beam to column web, and we're going to extend it. We'll do an extended plate so we can make sure the bolts are outside of the column web. So we'll do an 11-inch wide plate. This will be a single-sided plate, so I'll turn one of these off. A 3/8 plate, A36. We'll go into fit type. And we can make a 1/2-inch gap be our typical spacing here. And this is just setting how much we're going to cut back the framing in web and flanges of the beam. All right. Hole spacing will be our 3 inches. And we'll use an edge distance of 2 inches. And that'll set our offset out at 6, 5.5 from the face of the beam, and 6 from the face of the web of the column. We're going to have the 2 rows, I'm sorry, the 2 columns and the 3 rows, and again, our typical 3-inch bolt spacing. Now this is a little bit more edge distance than I wanted. That's being controlled by the total height of the plate. So if I came back to shear plates, I can lower this down to be a 9-inch tall plate. And then if we come over here, we'll see we have the 1.5-inch vertical edge distance that we were looking for. Again, we'll up these to the 3/4 bolts, and we'll look at the welds. We're going to want a 2-sided weld, 1/4 inch. Now, I've been doing these connections one at a time, but you can certainly save these templates and apply them a lot quicker. So let's go ahead and show that. We'll click on Save Template, and let's just call this the beam to call web. And here you can actually put in forces. So as you saw in the calc package, the engineer has supplied connections based on capacities and demands. If there were repeated sizes in here, you can determine which one you are going to use based on the demand of that connection on the contract drawings. And when you're saving in ASD, these templates, you can actually import those forces right here, axial, shear, and moment, so that you can relate those appropriately. For our exercise, we'll just leave those blank. So now we've created that as a template, and we'll apply that one to the connection. Okay, and if we rotate around, we'll see that, definitely went haywire with that other one. We'll see that we have the connection, and it's extended out past the web. Okay. And I'm rotating just like I would in AutoCAD, holding shift, using my center mouse wheel, and that gives me the option to rotate. All right, so now we'll look at a beam-to-beam connection and how we might apply some of those. I've actually got those in there, the templates, and so we'll just select a template and apply them quickly. So we're going to do the shear plate beam-to-beam web, and it'll tell you to select the main beam, and select the secondary beam, and it'll bring up the macro dialog. In here, you can see this is my W8 beam-to-beam. I'm going to select that connection, say OK, and you see the connection was quickly added. If there was something we wanted to modify, we can always use, again, the white circle to go into modify, and that'll bring back up our dialog box. In this one, I'm going to look, and I'm going to add the washers. So if I add these washers, we say OK, you'll see that those washers are added instantly. All right. And for completeness, I'll do a couple more quick connections. Shear plate, beam to column, or beam to beam. Beam to beam. I have a W12. I can apply that. So you can see once you have some templates set up, you can quickly apply your connections. And as most fabricators tend to use connection standards, those templates will be very helpful once they're set up. Once this process will be very quick for you. You can see that it's also coping the beams appropriately. So we have the top and bottom flange coped on that one. On this one, it coped the top flange as would be expected. All right, now you notice on this connection we have two in one place and one circle. If you're interested in selecting a connection and you want to guarantee which one you'll get, click on a bolt in the connection that you want. Then you'll see that the white line has gone dashed, meaning it's selected. Use the right-click modify, and that'll bring up your interface. Something went haywire when I made this connection, so I'm trying to figure it out. I think it might have to do with the height of my, yeah. So what happened was when I made this connection originally, I made the angle too short. So those bolts were extending through the entire column. If I kick this up to be a 9-inch tall leg, apply that, there's the connection I was expecting to have. Although not quite with the bolts up that high. Again, this shows you how nicely it is to come in and modify. Something's off with our top spacing, so we'll look into that. 1.5 inches, that seems right. Oops, I'm in the wrong connection. Let me get this one. Okay. And here's our problem. We had a spacing of -1 inch. So if we change this to 1.5 inch, and we have 1.5 inches, we have our 9-inch. Now we should be trying to get what we want. Here's getting closer. Here's the other problem. So this is actually nice because if you wanted to set in a stagger, you could. If you wanted to have the web bolts and the bolts into the column different, you can set that stagger based on this first bolt location. I think after all of those tries, I think we got the connection we want. That's looking a little better. And this also gives you a chance to check for interference visually. You can see if anything is clashing, and our connections look pretty clean. So what we're going to do next is look at creating some shop drawings from these models. The first step in creating shop drawings would be to assign a position, which is a unique identifier, to each different element. In order to do that, we can expand out some of these different items, adding the bolts, adding plates, and adding washers, gussets to our inspector. If your project inspector wasn't on, there's a button right up here to toggle that on and off. So you can hide it, have more modeling space, or you can reapply it in order to work with the individual pieces. Okay, so we're going to go and select all of the elements with the select all on the right click. And then up here we'll see the tool for automatic positioning. We're going to launch that tool, and for this example we're just going to let it default to its standard naming function. We can determine how we want these to be named, but we're not going to do that. So we're going to run it, and it's going to assign plates and columns and beams unique identifiers. Okay. So now if we go into positions, we'll see that we've populated this field in parts. Our families are being grouped together by beam. Our profiles of our beam show the different beams attached, and our plates. So what we're going to do is create the shop drawings for this first column that we modeled. To do that, we select the column, we right-click, and we choose Automatic Drawings. Now we're going to have to set up some scales. This can be saved into a template, so this would be something you would not have to do multiple times. But in this exercise, we'll do it. So we're going to first determine what size sheet we want to place it on. And I'm going to choose a Arch D size sheet. And we're going to set the scales to be 1 in 10. And again, this is just an arbitrary thing I've chosen. These scales could be whatever works best for you and your project and your standards. It's going to take a couple seconds to set these up for the different items. So I'll work through that. And again, this would be something you would save in a template and not have to worry about anymore. And you'll see that there are many different sheet sizes available, many different scales. And the last one. One in 10. Okay. We also have the option to add a bill of materials automatically to any sheet, and we're going to go ahead and do that. We'll just add the standard bill of material, and we could choose where we want to place that. We'll place it in the top left. And now we can go ahead and generate those shop drawings. So it goes through, reads the elements, reads the connections, and generates your drawing. So we can close that. And if we open this new drawing that appeared, you'll see that the shop drawing was quickly generated with all the weld symbols, dimensions, and part labels listed. So what I like to typically do is move this stuff to the side. It allows you to place it on the sheet wherever you want. You'll also notice that in the top corner, we created that bill of material, and you're seeing that it's already calculating some weights and getting out some material quantities for us. As these are columns, maybe we want to rotate these and show them in the vertical fashion. That's no problem. You can click, rotate, pick a point, and flip it around 90 degrees. This is a block, so it's selected with a single click. M for move. Where do you want to move it to? Same thing we could do with this one, RO to rotate. So I'm using the standard AutoCAD shortcut type keys. And again, we can go ahead and move this one if we need to. Okay. And that could be done for any of the other connections I drew quickly by just right-clicking on whichever assembly you want to look at and creating automatic drawings. Okay. Now to spice this up a little bit, maybe we'd like to add a little bit of a three-dimension look to it, give an idea of exactly what we're after. We can come back over here to the C1 position. I'm sorry, let's go back to our model itself. Okay. So first thing we want to do is group a couple elements together that we can show in an isometric view. So I'm going to choose the column, the beam, and the column that make up this front frame. And I'm going to choose to group those. And it's going to be a standard group. And the group name we'll call frame. And we'll base that on the universal coordinate system. Okay, and you'll see now in our groups we've created a new one called frame. And if we expand that out, it's made up of column 1, beam 1, and column 2. And within that, we can right-click on frame and choose to attach a document. And the document I'm going to attach is a southeastern view of the group in isometric. I'm going to choose that, and you'll see that now that's been added. And maybe this isn't exactly the way we want it to display. It's a little hard to see what we're showing here. We can go into the view itself, right-click, say to adjust the style. And we can turn off things like the invisible edges and add things in like the bolts and the parts. So this will look more like the connection we were looking to see. And we can say OK. So you see there that the bolts have been added and the different dimensions are showing. And from there, we want to add it to our drawing. We can go back in, looking at our sheet, right-clicking, and saying Add as a block to the current printout. And then we can bring that right in and quickly add a nice isometric. So this wasn't something complicated that you would necessarily need the 3D, but if you did, that's a quick way to show you how you can add a 3D to your shop drawings and really convey the intent to the fabrication guys and to the guys in the field. So I guess that ends my presentation as far as how you would use ASD. I'm going to bring back up our slides and open the field to any questions. Rosalie, were there questions?
Doesn't look like there's any questions right now, but if anybody thinks of questions, you can email Josh directly, or you can email the email addresses right on the screen there, or you can email webinars@microdesk.com. So that's webinars with an S at microdesk.com. If you want to go to the next slide, I'll provide some information as well. If you want to learn more, you can check out our website here on our course catalog. And then the next slide. I want to thank everyone for attending today's webinar, and thank you, Josh, for a great presentation. We have these webinars every Friday as a service to you. You can check us out at that website listed there. And Josh, if you want to leave this a couple minutes as well when we're done so people can take the information down. You can browse through our education consulting services. You can sign up for our newsletter, and there's a multimedia page there that you can see. We have all these webinars recorded as well, or you can contact us at the number below and at that email address that I mentioned earlier. Once again, thank you everyone for joining today's webinar, and we hope to see you at our next one.